Have you ever stopped to truly notice the small, colourful block that invariably sits by your kitchen sink? It's a humble object, often overlooked but undeniably essential to our daily routines. That's the dish sponge, an unsung hero of daily life, a silent workhorse that toils away tirelessly. It scrubs away stubborn food remnants, cleans sticky pots caked with yesterday's dinner, tackling the toughest grime with surprising ease, and keeps cutlery sparkling, restoring their shine after every meal, all without complaint. It's a thankless job, but the dish sponge performs it admirably. We rarely think about it, rarely give it a second thought as we rush through our chores. But without the sponge, imagine the chaos. Washing dishes would be a much tougher, far more unpleasant job. We'd be left wrestling with greasy plates and stubborn stains, longing for the sponge's gentle yet effective touch. Its soft yet sturdy texture, a perfect balance of give and grip full of tiny holes, creating a network of channels that trap dirt and grime, is the result of clever science and engineering, a testament to human ingenuity. But how does a simple rectangle of foam, seemingly unremarkable in its initial form, become the cleaning champion we rely on, the indispensable tool that keeps our kitchens clean and our lives a little bit easier? The story starts not in your kitchen, amidst the clatter of dishes and the running water, but deep in forests where the raw materials for some sponges originate, and busy factories where skilled workers and sophisticated machinery transform those materials into the sponges we know and use. From tree to supermarket shelf, a journey of transformation and distribution. The sponge's journey is a fascinating blend of chemistry, transforming raw substances into durable and effective cleaning agents, and manufacturing, carefully shaping and molding the sponge to meet our needs. Today, we'll pull back the curtain, revealing the hidden processes behind this everyday object, and follow this everyday marvel, tracing its path from its origins to your kitchen sink. From raw material to the tool, the indispensable item that makes our lives easier, simplifying our chores and keeping our homes clean. By the end, you'll see your dish sponge in a whole new light, appreciating the ingenuity and effort that goes into creating this humble yet essential tool. Let's begin the adventure and uncover the secrets behind the dish sponge. The humble kitchen sponge, a ubiquitous tool in homes around the world. But have you ever stopped to consider what it's made of? The main ingredient in most kitchen sponges is cellulose, a natural material found in plant cell walls. It's the very building block that gives plants their structure and rigidity. Think of it as nature's scaffolding. For sponges, cellulose doesn't come directly from your garden. Instead, it comes from wood pulp, a processed form of wood. So, surprisingly, your sponge begins its life as part of a tree, deep in a forest somewhere. These trees are harvested and processed to extract the cellulose fibers. This cellulose is what gives the sponge its incredible ability to soak up water and soap, making it an essential cleaning tool. The fibrous structure of cellulose creates countless tiny channels that draw liquid in. But cellulose can't do it alone. While it provides the base structure, other ingredients are needed to give the sponge its unique properties. Sodium sulfate crystals are added to the mixture. These crystals play a vital role. They create the sponge's signature holes. During the manufacturing process, the crystals are later dissolved, leaving behind a network of interconnected pores. Without these holes, you'd have a dense, solid, and ultimately useless block of material. The pores are what allow the sponge to trap dirt and grime and to be easily rinsed clean. To enhance the sponge's durability, cotton or hemp fibers are mixed in for strength. These natural fibers act like tiny reinforcing rods, preventing the sponge from tearing or falling apart with repeated use. This reinforcement is crucial, making sure the sponge survives all the squeezing, scrubbing, and twisting it endures during its lifespan. It's all about creating a product that lasts. Water and other chemicals, carefully selected and measured, help blend everything together, ensuring a uniform consistency throughout the mixture. This process transforms the raw ingredients into a thick porridge-like batter called viscose. This viscose is the foundation of the sponge, holding all the components together. This mixture is carefully prepared with precise attention to detail to ensure the final product meets the required standards. This is to ensure every part of the sponge is strong, absorbent, and ready to tackle the toughest cleaning tasks. Quality control is paramount. The result? A perfect balance of softness for delicate surfaces, durability to withstand rigorous scrubbing, and absorbency to quickly soak up spills. Each ingredient, from the cellulose to the sodium sulfate and the reinforcing fibers, plays a crucial role in the sponge's final form and function. The process is precise. One wrong step, one incorrect measurement, and the sponge simply won't work as intended. It's a delicate balance of chemistry and engineering. It's a recipe perfected over decades of trial and error, innovation and refinement. The modern sponge is a testament to human ingenuity. Next, let's delve deeper and see how these seemingly simple ingredients are transformed into the cleaning powerhouse we know and use every day. The journey of creating a simple cellulose sponge is far more complex than one might imagine. It all begins in the heart of the pulp mill, a sprawling industrial complex where raw wood is transformed into the foundational material for our absorbent friend. Here, massive logs are stripped of their bark, a crucial step in preparing the wood for its transformation. This debarking process removes the outer layer, ensuring that only the clean, usable wood fibers proceed to the next stage. The stripped logs are then fed into powerful wood chippers, reducing them to small, manageable chips. These wood chips are subsequently cooked in large industrial vats, a process that involves the use of various chemicals to break down the lignin, the substance that binds the wood fibers together. This intense chemical cooking process separates the individual wood fibers, creating a soft, fibrous wood pulp, the very foundation upon which our humble sponge will be built. It's a dramatic shift in form, from solid wood to a malleable, absorbent material. To ensure purity and quality, the pulp is meticulously washed, removing any residual chemicals and impurities that might compromise the final product. This cleaning process is essential for creating a sponge that is both safe and effective. Following the washing stage, the pulp undergoes a bleaching process. This is done to achieve the bright, clean and uniform look that we've all come to expect from our everyday sponges. The bleaching not only enhances the aesthetic appeal, but also contributes to the overall hygiene of the sponge. Once the pulp is clean and bright, it's then pressed into thick sheets, a process that removes excess water and consolidates the fibers. These sheets are the intermediate form of the cellulose, ready to be transported to the next stage of manufacturing. These cellulose sheets, now resembling large flattened mats, are carefully transported to the sponge factory, where the next phase of their transformation awaits. Upon arrival at the sponge factory, the cellulose sheets are submerged and soaked in caustic soda, a strong alkaline solution. This crucial step initiates a chemical reaction, fundamentally transforming the cellulose into alkali cellulose, a more reactive and pliable form of the material. This alkali cellulose is now primed and ready for mixing with other ingredients, a process that will ultimately determine the final properties of the sponge. The texture of the alkali cellulose is carefully monitored and adjusted, ensuring that it possesses the ideal consistency for creating a sponge with optimal absorbency and durability. To further refine its texture and prepare it for the next stage, the alkali cellulose is shredded into smaller pieces. The shredded alkali cellulose then undergoes a carefully controlled aging process, not unlike letting dough rise in baking. This aging allows the cellulose to develop the perfect final texture, a critical factor in determining the sponge's performance. This aging process is absolutely essential, as it directly influences the sponge's ability to absorb liquids and maintain its structural integrity over time. Once the aging process is complete, the cellulose is combined and meticulously mixed with a precise blend of other chemicals and additives. This mixing process is carefully controlled to create the viscose solution, a thick, viscous liquid that forms the base material for the final sponge product. With the viscose solution prepared, the stage is now set, and the real magic of sponge creation can finally begin. Inside giant mixers, aged cellulose crumbs are combined with carbon disulfide, turning them into sodium cellulose xanthate. Caustic soda is added, dissolving the crumbs into a thick honey-like viscose. Reinforcing fibers like cotton or hemp are stirred in for strength. Next, sodium sulfate crystals are added. These will form the sponge's pores, Special dyes are mixed in, giving sponges their vibrant colours. The result is a colourful, gritty slurry, the sponge batter. This batter is poured into large moulds, ready for the next stage. Every ingredient is carefully measured for the perfect texture and absorbency. The process is fast, precise, and designed for consistency. With the batter ready, it's time for the dramatic transformation baking. Let's see how heat brings the sponge to life. The batter is poured into huge moulds and moved into heated chambers. Steam or hot water triggers a chemical reaction, solidifying the viscose around the salt crystals and fibres. The block becomes firm and rubbery, but the salt crystals are still trapped inside. As heating continues, the salt dissolves, leaving behind a network of pores. The size of the salt crystals determines the size of the holes. Big crystals for coarse sponges, small for fine. What emerges is a giant, colourful, wobbly block full of holes. This is the heart of the sponge's absorbency. The block is still full of chemicals and needs a thorough cleaning. The creation of pores is a brilliant trick of chemistry, making the sponge light and absorbent. Next, it's time to purify the sponge. The sponge block is washed in large tanks to remove salt and chemicals. Heavy rollers squeeze and soak the block, flushing out impurities. Bleaching and softening treatments follow, ensuring bright colours and a pleasant texture. After a final rinse, the block is soft, clean and damp. Excess water is squeezed out, leaving a purified sponge block. This step is crucial for safety and quality. Only after this intense cleaning is the sponge ready for drying and cutting. Now let's see how it's shaped for your kitchen. Sponges come in bright colours for a reason. They catch your eye and make cleaning less dull. Colour coding helps prevent cross-contamination in the kitchen. Dyes are added during the batter stage, ensuring even, lasting colour. Special pigments withstand heat and chemicals, so colours stay vibrant. The pure bleached cellulose makes the colours pop. A fresh, colourful sponge signals cleanliness, while a faded one tells you it's time to replace it. Colour isn't just for looks, it's a practical tool for hygiene. Giant sponge blocks are trimmed and sliced by automated machines. First, the outer edges are removed for uniform texture. The block is cut into slabs, then strips, then final rectangles, the classic sponge shape. For 2-in-1 sponges, abrasive pads are bonded before the final cut. Sponges are sent through a drying tunnel to remove all moisture. This prevents mould and keeps the sponge fresh. Each sponge is inspected for defects in shape, colour and texture. Only the best make it to packaging. The process is fast, efficient, and minimises waste. Every step is designed for quality and consistency. Now the sponges are ready for their final journey. Let's see how they reach your home. Dried sponges travel down a conveyor to automated packaging machines. They're grouped, wrapped in plastic, and boxed for shipping. Packaging keeps them clean and shows off their bright colours. Boxes are loaded onto trucks and shipped to stores everywhere. The next time you grab a sponge, remember its journey from tree to kitchen. Every feature, from absorbency to colour, is the result of careful science and engineering. The humble dish sponge is a marvel of material science, making your daily chores easier. So next time you wash dishes, give a nod to this unsung kitchen hero.